For chapter 2.5, now we're going to be going over some applications of sets. So before we do this, there are several important phrases or keywords we have to watch out for, such as only set A and set B, and set A or set B. And also another one could be set A and set B, but not set C. So what we have to remember here is that and means intersection, or means union, and not means complement. Okay, so these are going to be important for the way that we set up our Venn diagrams. So that's what we're typically going to be doing here. We're going to set up a Venn diagram, and we're either going to have 2 sets or we can also have 3 sets. And when we are doing these Venn diagrams, we have to remember that we're starting with the intersection and we are working outward. So we're starting in the middle for what everything has in common, and then we're going to work outwards. Okay, so let's start with an example here. So at Erie Community College, a survey was taken to determine where the students studied on campus. Of the 250 students surveyed, it was determined that 167 of them studied in the library, 138 studied in the cafeteria, and 75 studied in both the library and the cafeteria. So of those surveyed, we wanted to answer all of these questions. So before we answer these questions, let's set up a Venn diagram. Okay, so we have our Venn diagram set up. So instead of using set A and set B, what I'm actually going to do is let's recognize the sets that we're working with. We're working with the students that studied in the library and the students that studied in the cafeteria. So let's use L and C to represent the sets of students that studied in the library and cafeteria. Okay, so let's label that on our Venn diagram. Let's call that set L and the one on the right set C. Okay, so let's take a look at our numbers here. We have 250 students total. 167 studied in the library. 138 studied in the cafeteria. 75 studied in both the library and the cafeteria. So what we have to do here is we have to start from the middle, start from the intersection. The word both is telling us that that is the intersection. Both, and then we also have the word and right there. So that's going to be the intersection. So we're putting 75 right here in the middle. And next we have to figure out 3 more things. We have to figure out what goes here, and then what goes here. So let's figure out for L, let's figure out right here for the rest of the library. This would represent they studied only in the library and not the cafeteria. Okay, so to determine this, what we have to do is take a look at the number of students that studied in the library. There are 167 that studied in the library. So what that means is we need this whole entire circle to add up to 167. So if we already have 75 in there, then that means the remaining amount is going to be 167 minus the 75. That's going to give us 92. So that means that number goes right here. Okay, so that whole circle for L had to add up to 167. We already had 75 of them, so to find the remaining, to find the difference, we had to subtract. Okay, so now we're going to do the same thing for the cafeteria. So based on the survey, 138 were in the cafeteria, so I'll just put cafe. So that means this whole entire circle has to add up to 138. We already have 75 in there, so to find the remainder, we have to subtract once again. So it's going to be 138 minus the 75. That's going to give us 63. So that's going to be 63 studied only in the cafeteria. And it looks like we only have one more section left before we can start answering the questions that we have. We just have to find out what goes on the outside here. And we find that based on the total number of students surveyed, which was 250. So all of the numbers in this universal set have to add up to 250. So that means in order to find that last number, we're going to subtract all three of these numbers from 250. So it's going to be 250 minus 92 minus 75 minus 63. We subtract those off and we get a value of 20. So 20 goes on the outside. We have all four regions filled in here, so we are good to go. Now we can answer all of these questions that we have right here. Okay, so for question A is asking how many students did not study in either the library or the cafeteria. So in the library, the students that did not study in the library or the cafeteria, that's going to be the number outside of these sets, which we just found was 20. Okay, so that's the answer to question A. For question B, we want to know how many of the students studied in either the library or the cafeteria. So the word or tells us it's the union. So it's going to be all of these values inside of these circles. So we have to add all of these up. So it's going to be 92 plus 75 plus 63. And adding those up gives us 230 students. Okay, for question C says how many studied in the cafeteria but not the library. So this whole circle represents the cafeteria, but 75 is shared with the library. So that means this portion right here is only the cafeteria. And the number in that section is 63. So that's 63 students. And for the last question, I have to rewrite this one real quick. Okay, there we go. I just had to rewrite it because it was the same question as question 2. So question D, how many students studied in the library but not the cafeteria? So for the same reason as the one that we just did, studied only in the library, that's going to be 92. So it is not the overlap, it's only the library. Okay, so that answers all of these questions. So let's do a couple more here. So for example, Best Buy has recorded recent sales for 3 types of computer software: games, educational software, and utility programs. So the following information regarding software purchases was obtained from a survey of 893 customers. So let's keep that number in mind. That's going to come in handy. So automatically when we see this, we should know that we're going to have 3 sets, a Venn diagram with 3 sets, because we have these 3 types of computer softwares. Okay, so we have 545 purchased games, 497 educational software, 290 utility programs, 297 games and educational software, 196 educational software and utility programs, 205 games and utility programs, and 157 all 3 types of software. So before we look at these questions, let's set up this Venn diagram. Let me zoom out a little bit here. Okay, so here is our Venn diagram with these 3 sets. And let's go ahead and label these sets. Let's say that we have games is going to be set G. Educational software will be set E. And then utility programs, I'm just going to call utility programs set P for programs, just so we don't get it confused with the universal set for set U. Okay, so let's go ahead and label these. And it does not matter at all where you place them. I just put games on the left, educational software on the right, and then the utility programs down below. Okay, so let's go ahead and start this the way that we usually do. We're starting it with the intersection between all of them. So we need to see what they all have in common, and that's going to be this value right here. 157 purchased all three types of software. So that means we put a 157 right in there. Okay, so working our way outwards here, the next ones we're going to do is going to be these ones. So we can pick whichever one we want. Let's pick games and utility programs. So let's do this one right here. So we go back up to our information. 205 purchased games and utility programs. So that's why I picked that one, because it was the next one up. Okay, so that means between games and utility programs, this little chunk has to add up to 205. So since that has to add up to 205, that means to find what is going to be right there, we have to do 205 minus the 157 that's already there. So when we subtract those, we should be getting 48. So that means 48 goes right here. So now the 205 is totaled up between games and utility programs. Okay, let's do the next one up. 196 between educational software and utility programs. So that means 196 has to be between these two sets right here. We already have 157 in there. So that means we have to subtract once again 196 minus 157. And that's going to give us 39. So what this 39 means, what this little portion right here means, that means that they purchased educational software and utility programs, but not games. Okay, so let's do the last one for this part, the games and educational software. So that is represented by this whole chunk. Since we already have 157 in there, we have to subtract. Hopefully that's getting pretty repetitive. We subtract and we are going to get 140. Okay, so 140 is going to go right here. So 140 customers bought games and educational software, but not utility programs. Okay, so now we go to the next level up. The next level up is going to be here, here, and here. And we're going to use the next batch of information that we have. That's going to be 290 purchased utility programs. So that means we are dealing with the bottom circle here for set P, utility programs. And that means everything in this circle has to add up to 290. So since we already have three different numbers in there, we are going to subtract. So it's going to be, let me write it right here on the side. It's going to be 290 minus the 48 minus the 157 minus the 39. That's going to give us a value of 46. So 46 customers only bought utility programs and they bought nothing else. Okay, next one up, we have 497 purchased educational software. So that's going to be this one right here that we need that for. So that means 497, a total of 497 should be added up in order to fill in that circle. We already have all of those values. So once again, we have to subtract it. So it's going to be 497 minus 140 minus 157 minus 39. And that's going to come out to a value of 161. Okay, so 161 customers bought only educational software and nothing else. Okay, and then the last chunk for this portion here is going to be the games. 545 purchased games. So that means this whole circle needs to add up to 545. And just like the previous ones, since there's already numbers in there, we have to subtract them off to figure out how many purchased only games. So 545 minus 140 minus 157 minus 48. That is going to give us a value of 200. So 200 customers purchased only games. Okay, and then the last step is to figure out what goes outside here, and that's the step, make sure that we don't forget. It's easy to forget that one. So to do that, we need the total number of customers, which is 893. So to find that, what we need to do is we need to do 893 minus everything inside of these circles. So I'll pause it and go ahead and just write these all down real quick. So that means we get a value of 102. So I'm going to put this right here. That means 102 people purchased neither a game, educational software, or utility programs. Okay, so now that these are all filled in, let's take a look at these questions. Now we can just refer to the Venn diagram. So the first one, we want to know how many customers purchased none of these types of software. And the answer to that would be essentially the complement of the union of all of these softwares. So it's everything outside of the sets, which we just found was 102 customers. Next question, we want to know how many customers chose only games. Only games is represented by this right here with no overlap. So we can see that that is 200. And question C is at least one of these types of software. So at least one, this means one or more. So that means they could have purchased one, they could have purchased two, or they could have purchased all three. So what this means is it's the union of all of these sets, which means we have to add together all of the numbers in all of these circles, in all of these regions. So if we add them all up, we actually get 791. So 791 people purchased at least one of these types of software. Okay, and then the last question, question D, exactly two of these types of software. So thinking about the regions for exactly two, this region is games and educational software. This region is games and utility programs. And this region is utility programs and educational software. So those regions represent exactly two. So what we're going to do is add that up. 140 plus 48 plus 39. And that's going to give us a value of 227 customers. Okay, so that is the answers for those questions. So let's move on to do one more here. So we have a travel company surveyed 125 potential customers. So let's go ahead and remember this number for the end. Okay, so we got the following information: 68 to Hawaii, 53 to Las Vegas, 47 to Disney, 34 to Hawaii and Las Vegas, 26 to Las Vegas and Disney, 23 to Hawaii and Disney, and 18 to travel to all three destinations. So before we take a look at these questions, let's set up this Venn diagram again. Okay, so we have three sets here, and label it the universal set for everything. And let's look at our sets. Our sets are going to represent Hawaii, Our sets are going to represent Hawaii, which I'm going to use an H for. Las Vegas, which I will use an L for. Well, I'll use a V for it, for Vegas. And then for Disney, let's use a D. Okay, so let's label this. I'm going to put Hawaii set right here. We'll put Disney set here, and Vegas's set down there. Okay, so let's take a look at this information that's given to us. So we have, to start from the middle, as usual, we're going to start from right here at the intersection. And that's going to be what they all have in common, and that is going to be 18. So 18 customers wanted to travel to all three, so that takes care of that already. Next one, we have 23 to travel to Hawaii and Disney World. So Hawaii and Disney World is going to be right here, the intersection between Hawaii and Disney World. So we already have 18 there, so once again we have to subtract. 23 minus 18, we get 5. So that means the amount of people that wanted to travel to Hawaii and Disney but not Vegas is 5. Okay, next one, zoom out a little bit. Next one, we have 26 wished to travel to Las Vegas and Disney. So Las Vegas and Disney is right here. So 26 needs to be in there. We already have 18. So 26 minus 18 gives us an 8. So that means 8 people wanted to travel to Disney and Vegas, but not Hawaii. And for the next one, 34 to Hawaii and Vegas. So that's going to be this portion right here, Hawaii and Vegas. 34 needs to fit in there. We already have 18. So 34 minus 18 is going to give us a 16. So that means 16 people wanted to go to Vegas and Hawaii, but not Disney. Okay, so now we finished that. So now we need to go to the next portion, which is going to be Hawaii only, Disney only, and Vegas only. So let's see what's the first one is going up this list. 47 wish to travel to Disney World. So that means this circle for Disney needs to add up to 47. We already have 5, 18, and 8 in there. So let's go ahead and subtract just like we've been doing. 47 minus 18 minus 8 minus 5. And that's going to give us 16. So 16 wanted to only go to Disney. And for the next one, we have 53 to Vegas. So 53 to Vegas, that means this whole circle for Vegas needs to add up to 53. We already have those numbers in there, so we have to subtract them off. 53 minus 16 minus 18 minus 8. And this gives us a value of 11. So that means 11 people wanted to only go to Vegas. And then second last for Hawaii, 68 wish to travel to Hawaii. So this whole circle needs to add up to 68. So we are going to subtract again. So it's going to be 68 minus 16 minus 18 minus 5, which gives us a value of 29. So 29 wanted to go do only Hawaii. Okay, and then the portion that we don't want to forget about is up here, the 125 potential customers, because we need to put in a number outside of these circles out here. So that means we need to subtract 125 minus all of these numbers in here. So when we subtract all of those values, we get 22. So that is when, that's the number of people that didn't want to travel to any of those places that they surveyed. Okay, so let's go ahead and zoom back in here and let's answer these questions. Question number 1, we want to know how many of those surveyed did not wish to travel to any of these destinations. So that's nice and easy. That's what we literally just said. That's going to be 22. So it's the complement of the union of all of those together, which means just whatever's on the outside. So 22. So we want to know for question B, how many wish to travel to only Hawaii? So only Hawaii is going to be just Hawaii and nothing else. That's going to be 29. Question C, we have how many wish to travel to Disney and Las Vegas, but not Hawaii. So here is Disney and Las Vegas, right where they intersect. But since it says not Hawaii, that means it can't be the 18 because Hawaii Circle is part of that. So that means it is just right here. This is where Disney overlaps with Vegas, but Hawaii does not overlap. So that is going to be 8. Okay, so let's make these a little harder here for these last questions. For question D, we have how many wish to travel to Disney or Las Vegas, but not to Hawaii. So the previous question we had the word and in there, which meant intersection. Now we have the word or. So since it says or, Disney or Las Vegas, that's a union. So that would technically be all of this filled in, all of Disney's circle, all of Vegas's circle. But then it says not Hawaii. So we're going to fill in everything we have filled in, except for Hawaii. So except for that green portion. So what's going to be left over is just going to be this portion, and this portion. So this is Disney or Vegas, but not Hawaii. So it's the complete circles for Disney, the complete circle for Vegas, subtracting off Hawaii's circle. Okay, so we have to add these up. So it's going to be 16 plus 8 plus 11, and that's going to give us 35 customers. Okay, and then the last part here we have how many wish to travel to exactly one of these destinations. So one of these destinations is represented by the outermost portion. So essentially it's only Hawaii, only Disney, and only Vegas. So what we have to do is add these up. 29 plus 16 plus 11, and that gives us 56 customers wanted to travel to only one of these destinations. Okay, so that is it for this section. So we start filling out Venn diagrams from the middle, we work our way outwards, and then we answer questions based on the Venn diagram.